Section 250.52a of the National Electrical Code addresses grounding electrode systems and the use of metal water pipes as grounding electrodes. The general rule is that a metal underground water pipe must be supplemented by an additional electrode as described in 250.53. However, exception 1 to 250.52 provides a specific condition under which you can ground to a grounded water pipe at any point within a building. This exception applies specifically to individually owned commercial or industrial structures. It is also crucial that the structure is serviced by authorized personnel. Authorized personnel refers to individuals like a dedicated maintenance department who are qualified and responsible for the upkeep and safety of the electrical systems. The significance of this exception lies in recognizing that large commercial and industrial facilities often have extensive and complex water piping systems. Requiring the grounding connection to be made only at the point where the water service enters the building might not always be the most practical or effective solution. The exception acknowledges that authorized personnel within these facilities can ensure that the water piping system is properly grounded and bonded throughout the building. Bonding refers to the practice of connecting metallic parts of a building's electrical system to create a low-impedance path for fault current. This is critical for safety, as it ensures that in the event of a fault, the current will safely return to the source, tripping a circuit breaker or fuse and energizing the faulty circuit. Now let's delve deeper into the requirements. The phrase individually owned is important. This exception typically applies to buildings owned by a single entity, as opposed to multi-tenant buildings or residential complexes where multiple owners or tenants share the water service. In such cases, the control over the water piping system and the ability to ensure its proper grounding and bonding is more straightforward. When grounding to a water pipe under this exception, it is vital to ensure that the water pipe is indeed grounded. A grounded water pipe typically has a connection to a grounding electrode, such as a ground rod, ground ring, or other approved grounding electrode. This connection ensures that the water pipe is at earth potential, providing a low impedance path for fault current. It is also necessary to consider the potential need for bonding around the water meter. Water meters often have non-conductive components that can interrupt the continuity of the water piping system. If the water meter does interrupt the continuity, a bonding jumper must be installed around the meter to ensure electrical continuity. The bonding jumper should be sized appropriately based on the size of the service conductors, as specified in Table 250.102 cone. This ensures that the bonding jumper can safely carry any fault current that might flow through it. Here are a few practical considerations. Firstly, always verify that the building meets the criteria for the exception, that is, it is an individually owned commercial or industrial structure and is serviced by authorized personnel. Secondly, inspect the water piping system to ensure that it is indeed grounded and that there are no non-conductive sections that could interrupt continuity. Thirdly, if a water meter is present, carefully assess whether a bonding jumper is required and install it according to the code. Fourthly, ensure that all grounding and bonding connections are made with approved connectors and are properly tightened to provide a low impedance connection. Fifthly, consider the size of the grounding electrode conductor connecting to the water pipe. The size of this conductor is typically based on the size of the service entrance conductors, as specified in Table 250.66. The goal is to provide a grounding path that is capable of safely carrying fault current. Remember that proper grounding and bonding are essential for electrical safety. They help to protect people and equipment from electrical shock and fire hazards. By following the requirements of the National Electrical Code and understanding exceptions like the one in 250.52a, you can ensure that electrical systems are installed and maintained safely and effectively. It is important to note that local codes may have additional requirements or restrictions. Always consult with the local electrical inspector or authority having jurisdiction to ensure compliance with all applicable codes and regulations. Proper interpretation and application of the National Electrical Code is crucial for ensuring electrical safety in commercial and industrial buildings. Understanding the exceptions and specific requirements, such as those related to grounding to water pipes, is essential for electrical professionals and maintenance personnel. Let's look into the specific language of the code. Section 250.52a generally requires the use of a metal underground water pipe as a grounding electrode, supplementing it with an additional electrode. This means that the water pipe, if available and meeting certain criteria, must be part of the grounding electrode system. However, the exception we are discussing modifies this requirement under specific circumstances. Exception 1 states that in individually owned commercial or industrial buildings where qualified maintenance personnel are on duty, the grounded metal water pipe can be used as the sole grounding electrode. The key here is the presence of qualified maintenance personnel. These individuals are expected to maintain and oversee the electrical system, ensuring that the grounding and bonding are intact and effective. Now, let's clarify some common points of confusion. One frequent question is whether this exception allows for the water pipe to be used as a grounding electrode even if it is not the primary water service entrance to the building. The answer is yes, provided that the other conditions of the exception are met. The grounding connection can be made at any point on the grounded water pipe within the building. Another question is regarding the definition of qualified maintenance personnel. While the NEC does not provide a specific definition, it generally refers to individuals who have the training, knowledge, and experience necessary to safely work on electrical systems. This might include licensed electricians, electrical engineers, or other trained personnel who are familiar with the NEC requirements and best practices for electrical safety. It is crucial that these personnel are not only qualified but also authorized by the building owner or management to perform electrical work. This ensures accountability and helps to prevent unauthorized or unqualified individuals from tampering with the electrical system. Moreover, the exception does not eliminate the need for proper bonding. All metallic parts of the electrical system, including conduits, enclosures, and equipment, must be properly bonded together to create a low impedance path for fault current. This bonding helps to minimize the risk of electrical shock and fire hazards. Furthermore, regular inspections and maintenance of the grounding and bonding system are essential to ensure its continued effectiveness. This includes visually inspecting connections for corrosion or damage, testing the continuity of bonding jumpers, and verifying the integrity of the grounding electrode system. Now let's talk about ground clamps. When connecting a grounding electrode conductor to a water pipe, it's crucial to use a listed ground clamp that is suitable for the purpose. The ground clamp should be made of a material that is compatible with both the grounding electrode conductor and the water pipe to prevent corrosion. The clamp should also be securely fastened to the water pipe to provide a reliable electrical connection. When installing the ground clamp, be sure to clean the surface of the water pipe to remove any dirt, paint, or corrosion. This will ensure a good electrical contact between the clamp and the pipe. Also, tighten the clamp to the manufacturer's specified torque to prevent it from loosening over time. It is also important to protect the grounding electrode conductor and the ground clamp from physical damage. This can be done by installing a conduit or other protective covering over the conductor and clamp. The protective covering should be securely fastened to the wall or other support structure to prevent it from being dislodged. Another important aspect to consider is the location of the grounding electrode connection. The NEC requires the grounding electrode connection to be accessible. This means that the connection should be located in a place where it can be easily inspected and maintained. The connection should also be protected from physical damage and environmental conditions that could cause corrosion. In some cases, it may be necessary to install a grounding electrode enclosure to protect the connection from the elements. The enclosure should be made of a non-corrosive material and should be properly sealed to prevent moisture from entering. In addition to the metal water pipe, there are other types of grounding electrodes that can be used. These include ground rods, ground plates, and concrete encased electrodes. Each type of grounding electrode has its own advantages and disadvantages, and the choice of which type to use will depend on the specific circumstances of the installation. Ground rods are typically made of copper or copper-clad steel and are driven into the ground to a depth of at least 8 feet. Ground plates are typically made of copper and are buried in the ground at a depth of at least 30 inches. Concrete encased electrodes, also known as UFA grounds, are made of bare copper conductor that is encased in concrete. These types of electrodes are typically used in new construction and are considered to be very effective grounding electrodes. Regardless of the type of grounding electrode used, it is important to ensure that it is properly installed and maintained. This will help to ensure that the electrical system is properly grounded and that people and equipment are protected from electrical shock and fire hazards. Remember that the NEC is a complex document, and it is important to consult with a qualified electrician or electrical engineer to ensure that all electrical work is performed in accordance with the code. Improperly installed or maintained electrical systems can be dangerous and can lead to serious injury or even death.